I'm doing problem 24.19. The problem states, the figure 1 shows 3 Gaussian surfaces and the electric flux through each. Part A is asking what is the charge Q1, B, what is the charge Q2, C, what is the charge Q3. So what I did is I redrew the picture, figure 1, and I color coordinated it, the closed surfaces to make it more clear. And Gauss's law states for any closed surface enclosing the net charge Q, the net electric flux through the surface is, I wrote the flux is equal to Q over epsilon naught. Also, the charges outside of any surface contribute to the electric field, but not to the flux, which is why it's not included in the equation. The figure shows that the flux of A is negative Q over epsilon naught, B is 3Q over epsilon naught, and C is negative 2 over epsilon naught. And so I wrote down the net flux of each closed surface. This is A, this is B, this is C, and this is B. And just to simplify, I excluded the Q over epsilon naught, but from there, I set this equal to, or I isolated Q3. So Q3 is equal to negative Q2 minus 2. And then from there, I solved for Q1, and in this case, Q1 is equal to 3 minus Q2. From there, since I have everything in one variable, which would be Q2, I put it into the equation, into A, which is negative 1 equals Q1 plus Q3. But when I isolated each one, it is now negative 1 equals 3 minus Q2 minus Q2 minus 2. From there, 3 minus 2 is 1. The negative Q2 minus Q2 is negative 2Q2. And from there, I just isolate Q2 and we get 1Q. Now that we have Q2, which is just 1Q, we put that in for the flux of B. So negative 2 equals 1 plus Q3. Isolate Q3, that's negative 3Q, which is equal to Q3. Then we do the same thing for this one. And that is that's the flux of A. Now that we have Q3 and Q2, we should just get our answer, and then we isolate Q1. So this would be negative 1 is equal to Q1 minus 3. So Q1 is equal to 2Q. Thank you.